Okay. Well, please. Let's go through the end of chapter 3 before we start into chapter 4. Okay? And in chapter 4, we're going to learn a lot about the I/O process, the input-output process that is going to be the key to you passing the exam. We're going to go through a number of commands that I invite you to use in practice to learn their syntax. One of the unfortunate things about learning a language is that you have to split your time, your mental energy, between the syntax and the semantics. Semantics meaning the meaning, the syntax meaning the structure or format. Getting either of those two things wrong means you're improperly using these statements. So you have to understand what the statements do and how to properly code or the proper syntax for the statement. So we all know what the modulus command does. I'm just going to run through these things real quickly. The postfix and prefix, increment and decrement commands, we should all be aware of. We haven't used them yet, but we will use them quite soon. And our precedence table. Our precedence table here allows us to use our understanding of operator precedence to make clear the proper evaluation sequence for expressions. And as I'll continue to note, always, if you are unsure about precedence, always use parentheses to explicitly indicate how you want a statement to be evaluated. And notice that at the very bottom operation is the assignment statement. So once the right-hand side of an expression that involves an assignment statement is evaluated, then finally the assignment statement itself, operator, is evaluated and the data result is placed into the receiving variable. That's, again, just mathematical, straightforward behavior. So I went through this exercise last time. I'm not going to go through it again, but I suggest if you expect something like this on our exam next week. And I'm just going to go through these rather quickly before I move on to chapter 4. If you have a question, please stop me. And you remember our concept of coercion, where we have values that are at times involved in arithmetic that is integer because of integer operands, or floating point division because of its operands, or at least one of the operands is of a higher precision float data type. Yes, sir.
So there's no definition, like there's no specific, like, was there difference between float and double? Like, so at least, like, what is, I still don't understand, like, the difference.
You really, from a programmatic standpoint, at this point, you don't really need to use double. Okay?
So, like, the last program we did in assignment 3, when I did my program, it was like, it gave me warnings at first. Like, sometimes it was just giving me warnings, but it was still compiled. But sometimes it wouldn't let me compile. I had to change the float to double.
Okay. That happens. Obviously, it doesn't happen all the time. But you should know enough now to realize that that warning means that when you do the initial assignment of 3.04 or something like that, that you actually, the literal 3.04 is a double. And if you're assigning it to a float, it will tell you that it is coercing the value as a warning. Okay? So if you want to get rid of your warnings, or in some cases you want to make it compile clean, just change it to double. Use float or double interchangeably, whatever it takes. But just don't be concerned. You're not dealing with numbers that large in this class. And I'll move forward here. I think everybody should understand what happens here. Let me just go over it real quickly with you. That integer 4 is cast by this function. This is called a casting function. Casting and coercion go together. Casting is explicit type conversion, and coercion is, coercion is, well, there's no coercion in this slide. Coercion is implicit type conversion. So here we are already converting or casting the integer 4 into 4.0. Oh, here's a coercion, which causes the integer operand to be coerced into a float so that floating point division can take place. Any questions about this mixed type expressions and how casting and coercion is done? You will need to use those concepts frequently as you write programs over the next several weeks. Oh, remember I took some time in class a few weeks ago to comment that this is an expression and that is an operator? And just as all other expressions that we've encountered so far are evaluated, this expression is evaluated and its output is Cout. This expression, which you should all also be familiar with, Cn, getting information from the keyboard, is also an expression, and that's an operator. And its result of evaluation is Cn. Yes?
On the example before the 0.5, why are the 4 and 8 coerced with that one?
Right here?
Yeah.
That. Remember precedence. Remember precedence. What is the operator with the highest precedence? Parentheses. So what takes place first is what's inside that parenthesis. And that is integer operand and integer operand, and its process of integer division, and the result of that integer division is what? 0.
And when the float just puts 0.0, right?
The float takes the 0 result of that expression's evaluation and casts it into a floating point value, and that's why it's evaluated to be 0.0. There's nothing hard about this. Once you get the idea, it's, it's pretty straightforward. So, here we see something that we haven't encountered before, and that is an operation that does what? Can anybody give me a guess? Okay, can anybody tell me what you think that expression is trying to do? Let me give you a hint. It's in your book. It's conducting an operation called that begins with the word on. Recursion? Good guess, but no. Somebody's reading my chapters, aren't they? Have you encountered the concept of rounding before? Rounding. What is this thing doing? Okay, thank you. I want to go through a real quick.
But I thought if I calculated it wouldn't automatically round.
It will not automatically round. And that formula that I've just pointed to you accomplishes rounding. So I'm going to put some values to my algorithm. I'm going to do a little test oracle here. And we're going to see if that formula actually will round the value. All right? So we have cost. Sorry, we have low cost. I've got to move that over just a little bit. Can you just bring that over so I can get that L in low cost and that H in high? Perfect. Good. All right. So we have this value, 12.342. And what we first do with that value is we multiply it by 100, which effectively turns it into 234.2. We multiply it by 100, we move the decimal places 2 places, the decimal point 2 places to the right. Okay? I make mistakes too, but am I right?
Right.
Okay, good.
All right.
Help me out, help me out. So, what am I trying to do? I'm trying to achieve a rounding operation on that low cost variable value. And so I would hope that I'm going to come out here with something like 3 point.
No, hold on, but you still have to add plus 0.5.
Yeah, I just want to get an idea of what I'm trying to get to see if I get there. All right, so I want to know the destination before I conduct too much of the journey. So everybody sees that I'm trying to round it, and I believe I'm rounding it to the 100th place, but let me see what happens when I apply my algorithm. So now I'm going to add 0.5 to that. Means I come 2, 3, 4, 0.7. Now what do I do next?
No, it says you have to make it an integer. Basically,
That's
you take off
exactly what I do next. So,
make it integer.
an integer, right? So
You should just take that off. Yeah.
correct? And after I do this, and then what do I do next?
Make it a float. You gotta make it a float.
Thank you.
No, you said parentheses.
So I say it one more time.
No, you gotta know. Look.
Okay, watch. First, let me just step back a second. Step back a second.
Oh, no.
First I multiply.
Okay.
Then I add it to it. Then this parentheses and this parentheses match up, and I do a casting of it to an integer. Then this parentheses and that parentheses take place, and I cast it into a float. So now it's this value.
1,003.
And I divide it by 100, and that gives me the floating point value of 12.34, which rounds it to the 100th place. So let's see what happens when I round high cost.
The same thing, except they don't pay.
Oh, the same thing doesn't happen. The result comes out differently. My high cost is 12.348. I multiply by 100, which makes it 1,234.8. I add 0.5 to it, which gives me 1,235.3. I then, what do? I cast it into an integer. Then I cast it into a float. Then I divide by 100, and now I have I have rounded that value into 12.35.
Oh, yeah.
See how that works? Okay, so now, yes, sir, in the back.
Yeah, is it necessary to follow the
I got someone talking a little louder than you in the hallway. Can I ask somebody to close that door for me, please? Thank you. One more time.
Would it result any difference if it was close?
If you do what again?
If you didn't put float,
Oh.
If you divide it by 100.
That would be time.
Right. In other words, I guess the question is, do I have to cast it, or will it already be coerced because I'm dividing it by a floating point, and you're absolutely correct. But just to be explicit in our formula, it's a good idea to just make sure it happens, but it would not be absolutely necessary. Okay, so my question to you is the following. How might I modify this formula so that I could round to the 10th place?
You have to add another 0 to 100. Make 100,000.
That was a good guess. Everybody agree? All right, let's see if it works. Let's come up with a value that obviously if we round it to the 10th position, it'll round up. So how about 12.37?
But we have no other numbers on the left side of this. We have to add another number to those numbers. Like add
You could imply it was 0. It could be 0 if I didn't put anything there.
Well, yeah.
It would be 0. But let's we'll do this number.
We're rounding
So
to the 10th position.
we're rounding it so that our result will hopefully be what? 12.4.
Okay.
And your classmates speculated.
No. No, that's wrong thing. I had it wrong. I messed up.
So what are you saying? What do I change?
You gotta change the 100 to
100 to
10.
10.
Yeah,
100 to 10.
I win.
And then this to the 10 as well?
Yeah.
All right, let's see if that works. First thing I would do is move my decimal place over because I'm multiplying it by 10.
Okay. Now add 0.5.
I add 0.5 to it, so I
Oh, you might not need that extra number though.
Yeah.
we'll worry about it. Okay, so now I've added my 0.5 to it. What do I do next?
And then you make this an integer, make it into a float, and then divide by 10.
I think you have to
I got my 12.4. Okay, so this value and this value tell us what? What place to round. So we should be able to come up with a rounding function of our own that could do to 1,000. How about rounding it to the next largest whole number? What would I do there?
You said the next largest.
Whole number or integer value.
Wouldn't you just make it 1?
Okay? Let's be a bit inventive here.
Wouldn't that be
If I wanted to round that to the next largest integer, that would be 124, correct?
Yeah.
So let's come up with our own formula. Let's learn from this, but I think we can come up with our own formula to get this done.
Alright, if you understand, then it will be like the same concept.
Okay, hold on. Let your classmates marinate and think about this for a second. What's the formula for rounding this number? You should come up with your own algorithm, right? Again, taking what you learned from here, can you come up with your own algorithm to allow you to do this? Well, let me push it on a little bit. What you want to do is you want to get a 4 here, correct?
Yeah.
Or, if that were less than 5, you'd want to keep it a 3. Okay? So what might you do first to this in order to get a 4 here?
To get a 4 there, wouldn't you add 5?
5 or
5 or
0.5?
Oh,
We're close. So the first thing I do is I wouldn't need to multiply by 1, yes, right? Because what does that do?
It keeps us in the same decimal, the same place. What you call it?
Multiplying anything by 1 is unnecessary. Okay? So we can take that out of the formula. That's essentially what we did. We're adding 0.5 to it, which gives us 12, 4, 2, 2.
and then make it so integer.
Make it into an integer,
That's it.
and that's our result. We just wouldn't need to do that float on the end. And you wouldn't need to divide by 1. Again, divide any number by 1 is what? All right. Okay? So, any questions about that rounding algorithm? Okay. I got a number of questions coming to me about what do I mean when I say test oracle? What is this?
It is the calculations that you do before you do the algorithm.
Well, no, it's the way in which you test your algorithm with handwritten data. That's exactly what I just did. I tested my algorithm. We'll continue to do this. Okay, so just a little bit about argument lists and parameters. I mean, these words are used quite frequently in our lecture and throughout our book. So I want you to understand that they are what they mean. So let's take a look at, okay, let me go back a second. This is a function that raises a value to a power. Okay. This parameter is a floating point, and this parameter is a floating point. Here's an example of that call, and here we have 2 floating point values, 2 and 3, and of course the output is 8, which is 2 to the 3rd power. Okay. Did we use that recently? Where do we use it? Anybody remember? Anybody other than my friend here in the front row?
Last time, in assignment 3.
Right, we were trying to raise something to
The
the
interest thing.
I'm sorry, did it work?
No, I said that's on mine, it works, I didn't put it.
I didn't know it was a flow.
I didn't put it forever.
Okay. So we've used function calls with parameters before. Okay. So we'll be using that a lot. As a matter of fact, not just a lot, we'll be using it in almost everything we do from this point forward. So please get an understanding of how that works. Yes.
Sure, I was kind of like I really didn't understand. Like when you say function call, that's basically giving the execution power from the main function to the secondary function, right?
I'll say it in other words. Yes, you're right. It's transfer of control from the calling function to the call function. When the execution sequence encounters a function name, that constitutes a call to that function. So if we see cout, something, something, a function name, that's an execution transfer to the called function. So the call function takes over control, primitive is processing, and returns back to the execution sequence in the same spot to which it was called.
So when you basically, and we have a secondary function, you have to declare a secondary function as you have to declare a constant outside and before the first main function.
That's correct.
Right.
That declaration is called a function prototype.
Okay. And then after, like, because this was a confusing part, basically after the function, the second function, you have to take that. When you, like, the lab, you wanted us to take the outcome of the second function and put it back in one. When you do that, the variable, like, could you explain, because I already, that was kind of weird to me, how do you take them, the variables? How do you basically take whatever you got from function number 2 and put it back in function number 1? Or is that like not what
No, we saw that the very first day. We saw that with our cube function. That's my function prototype. In main can cout cube 27. And so your question was, how do I get the result from my cube function?
Oh, it declares it in the. Oh, okay.
Please, let's not have these running in consciousness, verbal consciousness. Dialogue going on. So, okay, so x would be my square and x would be my cube. So the question was, how do I get it back? Well, it's an automatic operation. Once I make the call and give execution control to this function, it returns the value back to the same place in which it was called. Okay, that's how you do it with the return statement. So yeah, that's your question?
Yeah.
Okay.
Yeah, you got it.
Let me confuse you even more.
Okay.
Suppose we had a square function.
So we have 2.
Wouldn't you just put 2 at the bottom?
But she square.
And you can imagine what a square function would look like, right?
Yeah.
Okay? Can I do this? Call the square function from within the cube function?
But have you,
No,
you haven't declared square yet.
Well, let's. Yeah, I've run out of space. Okay, I could write the square function, but I don't want. You can imagine what the square function does, right?
Yeah.
Okay, so just imagine it. Okay? Can I call the square function from within the cube function, and the cube function still perform the cube of 27?
So you're taking basically.
Oh. Don't ask me a question. I'm asking you a question first. All right? Let me get a yes or no here. How many people think that this is syntactically and semantically correct? How many people, put your hands down for a second. How many people aren't sure? All right, then I need to talk about
Wouldn't
this
it
for a
have to
minute.
be the same number?
It is. Good question. Good question. Okay? Matter of fact, let's not even make it the same variable.
Oh, I see what you're saying.
So it's x up here in the prototype, but now it's y down here in the definition. It's x in the declaration, and it's
That's a whole different thing. That's a different thing.
syntactically correct.
No.
Ah, okay. Now I understand what your confusion is. Let me clear this up. I think this is very important. In the function prototype, the variable name is just optional. Okay? It's not necessary and it's totally meaningless. Okay? It does not constitute a global variable. It's just documentation oftentimes. And really what it is that people, the reason even the C++ designers put it is so that you could copy your function header with your variable name and your variable type and put a semicolon behind it and make it your prototype. That's all the reason it was done. But right now, I'm going to clearly make it obvious that X is not necessary here. But we've got to go back to the fact that some of you still thought this was semantically and syntactically incorrect. Let me give you the answer to the question. This is perfectly allowable. I have a function being called. Y is given the value 27. And from within that function, another function is called that sends that 27 to it. And the return that will be at the end of the square function, if I were to write it, would return the square of 27 multiplied by 27, giving me the cube of 27, and then return the cube of 27 here, and it would work fine.
But you would have to write down the function for square first.
Certainly. I'd have to write it down either here or after here or here.
That's the confusion I have with your
Question here.
So basically what you say that it's not only the main function that can call functions, like other subprograms can call functions.
That's absolutely right. Go back to our first week in class when I put up that structure chart for type of party. I had a get refreshments function that called get drinks, get food, which could themselves be, get wine, get beer, Function can call other functions. It can go down very, very deep. A function even, and I'll just throw this out for thought, can call itself. That's called that R word. I heard it over here before. It's called recursion. We're not going to get into that until next semester. I had a hand here? Yes.
All right, just to add, if that would be syntactic, like if the square function had more than one variable, like if you had like 3 different variables within the square function, wouldn't that be semantically wrong?
Well,
Or
you would not write a square function unless you had some particular reason for having more than one parameter. Square just being clearly. There's a concept in the computer science called functional cohesion. And it's a big word that simply means if you got a function name, it should do what it says it's got to do.
Well, I'm just saying, like, all right,
You would not have 4 parameters to a square function. You might have 4 parameters to a calculate monthly payment function. And if that were the case, when you called it, it should have all of those variables with values that are properly typed and in a proper position in the parameter list that corresponds to the prototype.
Yeah, just like I was also thinking of the lab that you gave us Tuesday, because you had 3 different variables.
And you'll see 3 variables, not 3 variables. you'll see functions with multiple parameters in its parameter list. We need to get familiar with this language because this is the language that you're going to encounter in the quiz and exams. So let's talk about parameter lists and not variables. Parameters. And when you send, there's formal and informal parameters. I think I even talked about that at the end of these slides. The number names for this. These are not variables. Okay? Variables are what you declare inside main or inside another function or outside of main, which determines whether it's going to be global or local. Okay, let's move on. So here we have a square root function. And square root function, by the way, is brought in by our CMath library. That's included as part of our initial directive, compiler directives. And here we have something that we haven't encountered before. We have a function call whose parameter is an expression. Syntactically okay? Well, age is usually an integer. Okay? So now we've seen some other little modifications to our concept of parameters. Parameters could be calculated before they're sent. For example, I could say square root of 20 plus 7. Or I could say the square of the cube of 34 minus 7. And that expression, 34 minus 7, would be evaluated to 27, and the integer value 27 would be sent just as it is over the board. And again, I'm often trying to confuse you, but let me hopefully not this time. Inside my parameter list, I could have a function call, a value returning function, that before square root is called, that parameter, that expression is evaluated, and that expression has a function call that is now given control, returns a value, and then becomes part of my parameter value that is sent. Okay, let's move through some of this because it's redundant. Okay? You should all know what this does. So we have been talking about value returning functions. However, there are void functions, functions that do not return a value. And I'm going to be asking you to write a void function to do nothing more than to display at the top of your output your name, your ID, the date, and the assignment. That will be a void function that does not return a value. It just is given execution control by the main and just does its coutts and then returns it back to main. The difference is a value returning function. So if I can get to this for a minute. Nope, I don't have an example. This board is probably hard for you to see. Having taught this class for quite some time, I know where the confusion is going to come in when we have a value returning function and a void function. The confusion is going to come as into how do you call a value returning function, and is it different from how you would call a void function? So I want you to write a function, a void function, called heading. I'm not being hypothetical here. I'm saying I want you to write this function. Yes, sir?
Can you move the projector to the right?
You can't see it?
Right here, you just do so it would just be easier.
The projector to the right. In other words, you want to see light? You want to get light on this board?
Right.
Okay.
Oh, yeah.
No, let's go back. Can you see this? Okay, if you can't see, just move up, all right? So I want you to write a function called heading. Has no parameters. That's my function prototype. Inside your main, again with no parameters, I want you to call this void function. Can anybody tell me how to call that void function?
See out. Operation operator.
See out, if it were see out like here, it would have to be a value returning function. Because the call would need to return a value here so it could be see out.
Could you just write heading with a parameter?
That's it. That's a function call to a void function.
But then how would you, you said you want us to do a void function with like our name and stuff like that. How would you do that if that?
Can I write on that board? Can everybody see that board? Okay. Here's how you would write it. First of all, the function header would begin with what? Do I have parameters? And as I said, what I want you to do, I want you to see out. Oh, let me show you something here. I can put an indel on there, right?
Yeah.
Can I do this? Yes. That's the same thing as putting an indel on there.
You just have to have the little operator.
My ID?
No, the two lesson terms at the end of that.
Nope.
You don't need it?
Nope.
I thought you had to have it on each side, like beginning
Nope.
and end.
That's an operator. That's like A plus B. I wouldn't say A plus B plus. Does that make sense? Yes.
Is it that? It's a backslash or that slash? Is that?
Oh, I'm sorry. It's a backslash. Okay. Can I do the same thing here? Now, assuming I finish this out with date and the name of my assignment, do I need a return? No. It'll give you a syntax error if you put a return in a void function. Everybody got that? Yes. Okay, great. Oh, by the way, this is a what kind of operator? Binary or ternary? Binary. Can anybody give me any binary other binary operators?
Or quotes?
No, that means
And or
relational operators are binary. What about plus, minus, division? What does binary operators mean? Two operands. Okay? Do I have any single unary operators? What are those? Anybody give me an example? Sorry? That's an operator. What about our post increment and post decrement operators? Unary. Okay. Be sure to look on the website for our assignment number 5. It'll be due next Monday. The algorithm will be due on Wednesday. So you need to look at it like now. All right?